Hello, this is Jamie Powell at INSYDIUM, and in this video we're going to create this crystal smash animation. We'll use MeshTools to build the system to modify our base object, which will be a sphere. And from that we'll get the illumination that we can see in the video, and then the crystal-like shards breaking out of that structure. So let's go to our scene. And as we can see, we have some lights in the scene already. And if we open up this group, we can see they are Cinema 4D lights. That's because we're not going to focus on Cycles 4D rendering in this video, just the build in the scene. So we'll turn on the inside light later, and that's because we have this crystal material that we'll apply, and this inside light is going to illuminate it from the inside for our viewport render. So let's bring in our base sphere. Let's just hide the lights. We'll go to the Objects menu and let's choose a sphere. Let's go to the Viewport and go for Garage Shading Mode with Lines under the Display tab. And if you look at the sphere in the viewport, we're going to reveal the polygons that make the sphere. So down here in the Sphere Attributes Manager, in the Object tab, we can see that the type has been set by default to Standard. And that gives us this type of sphere in the viewport. We're going to change the type though to tetrahedron and have a look at the sphere. The design of that sphere is going to change. Let's investigate this. So we have this tetrahedron design on our sphere, and it's just a little bit more unusual in comparison to the standard sphere. This is going to give us a really good base for when we remesh our sphere and start to create the base of our crystal-like shards. So let's put our sphere inside of a MeshTools remesh. We're going to remesh our base sphere. Let's click the sphere. We'll leave the segments at 16, which is the default inside of the Attributes Manager. And then we'll go to the INSYDIUM menu here at the top, MeshTools, and we'll find the MeshTools remesh here at the bottom. And with our sphere selected inside of the Objects Manager, if we hold down Alt and then click the MeshTools remesh, the sphere becomes a child of the remesh and is therefore being affected by it. So inside of the Remesh Attributes Manager, down here on the bottom right, we can see that the mode is set to uniform, and therefore all of the edge lengths that are remeshing our sphere have a uniform edge length of 10 centimeters. Let's increase this to 25 centimeters to make our polygons larger. This will keep our scene nice and fast in the viewport, and of course, because our rig is going to be procedurally built, we can always go back to this later to increase the density of polygons and therefore the quality of our render. Let's leave it at 25 though. So we'll pull this out so that we can see our options a little bit more, and we're going to go to the shader menu and bring in a noise shader. So we'll go to this drop down menu, we'll choose noise, and we're just going to leave the noise at its default settings for now. The way that this works is that inside of the shader we have different brightness values. So we have these darker areas and then these brighter areas. And it's the brightness that determines where on our sphere we are remeshing. The tolerance slider here below adds bias to this. So if we take the tolerance all the way down to 0%, we are remeshing the entire sphere. And if we bring this up further, we'll see those polygons start to increase in size because we are remeshing less and less of our sphere. So what we can do is find a position in between 0 and 100 where we get this really interesting blend of remeshed polygons and non-remeshed polygons. So therefore we get this really interesting disruption of the base mesh of our sphere, as we can see here in the viewport. So we'll leave the tolerance at 52.6%, and we're going to leave all of the other settings as they are for now. Now though, we're going to take our MeshTools remesh object and put that inside of a MeshTools subdivider. So with the remesh selected here in the Objects Manager, we'll go to the INSYDIUM menu, MeshTools, we're going to select the subdivider whilst holding Alt down again. And once more, the MeshTools is now a child of the subdivider, and we are therefore subdividing the remeshed polygons. So if we increase this subdivision level to 2, we're going to see many more polygons generated. Again though, let's choose a shader. We'll choose the noise shader once more. And we're going to decrease the tolerance to get some more of those extra subdivided areas. Again, we have this noise shader which is using brightness values to determine where we have the subdivisions occurring. Now, with our subdivider selected, we're going to put this inside of a MeshTools inset object. Again, we'll go to the INSYDIUM menu, MeshTools, and we're going to hold down Alt and select the MeshTools inset object. So the way that MeshTools inset works is it insets the polygons. So let's demonstrate this whilst turning off the subdivider and the remesh, and we're just going to inset our base sphere. So keep an eye on this polygon as we increase the inset amount. So at 0% we have this normal result, we just have the base sphere, but as we increase this amount, we can see that we are generating these additional polygons within those base polys based on this inset amount. Let's continue to increase that amount all the way up to 100%, and now we have this really beautiful result. Then we can offset this too. So the offset, if we increase that, is going to enable our newly inset polygons to be offset in their position. So with an increased offset value, they stick out of our base mesh. Now above here we have divisions. At the moment we have the division set to 1, so we don't see any result in the viewport. But if we increase this to 2, we can now see that we have these horizontal subdivisions along the length of our offset polygons. Let's increase the division number to 3, and we can see the divisions increase in count. Let's continue. We'll go to 5. Again, we can always come back to this later to increase this amount if we want to. So now let's introduce some twisting. If we start to increase this, we're going to see our offsets start to twist around. Let's go all the way up to 180 degrees. So as we can see, we have this really beautiful result at the moment, but it looks a little bit too uniform. Let's add some variation to this. So we'll add some variation to the amount first, but to demonstrate this, let's take all of the twist off. We'll put this at 0 degrees and the offset 2. And we're going to increase the variation up to 50%. And as you can see, when we increase the variation, we have differing amounts of insets. So when we had the variation set to 0%, we were insetting at a value of 100% everywhere. But now we have a variation set to 50%, we have that 50% leeway. So we get different results on each polygon. Let's bring the offset all the way back up to 100. And let's increase the variation here. Let's go to 70%. And now we have different amounts of offsets. So we no longer have all of these offsets the same amount. We have some shorter and some longer shards. Now let's increase the twist back up to 180 and then increase the variation. And as you can see, we get different amounts of twisting occurring. So you can use the variation here to break up the result in your scene and make the result a little bit more organic. Now let's turn back on our remesh and have a look at the result. So already we're getting this very cool crystal-like structure. Now let's go to the Fields tab and we're going to control all of the amounts of inset, offset and twisting with a linear field. Let's create the linear field, and as you can see, we don't quite have the result that we expected. If we go back to the picture viewer to look at our reference, we get the crystal-like shards appearing from the top down, not from the side. So let's just go back to our viewport, and that means that we need to reorientate our linear field. Let's take it out of the hierarchy, and we'll go to the Fields tab, and we need to change its direction to Y+. Now it's aligned along the Y-axis, and if we move it up and down, we're going to see those crystal-like shards start to reduce in strength. So that's looking great. Now let's go to the linear field and let's reduce its length to 50 centimeters. And we'll also go to the remapping tab, and we can change this linear strength. So at the moment, at the bottom of our linear field, we have a strength of 0%. That's why everywhere below this point of our field on our sphere isn't showing those crystal shards, but we are seeing those crystal shards everywhere above that. And that's because the strength goes from 0 to 100. So if we go down here to the contour section, let's just choose the quadratic for now and extend this attributes manager. We can change this fall off. So if we increase the percentage on the curve, we can see that we get this different result in this visualization of our field. This is going to mean that we have less strength for longer, and then we're going to ramp up to the full amount of strength. So therefore, we get more of this cracking occurring, and then we have this more crystal-like explosion towards the top of our field. Now let's animate this in. We're going to bring in the dope sheet, so we can click this button here to bring in the timeline. And we're going to go to frame 40. And at frame 40, we want our linear field to be completely above our sphere. So let's put this here. Just check the coordinates. So 150. Let's keyframe that here in the linear field coordinates tab. So that's on the y-axis. And then if we go forwards to frame 80, we're going to bring this all the way down to about there, so 20 centimeters. Let's keyframe that again. And if we bring our linear field into the timeline, we can see the keyframes that we've just created. So let's go back to frame 0 and we'll hit play. We'll see that linear field push through and those crystal shards explode out of our sphere. So already, in just a few minutes, we've created a very complex looking animation very quickly and very easily, just using a beautiful MeshTools hierarchy. Now let's go over to frame 180. We'll go back to our linear field and we'll create another keyframe here. Then at frame 220, let's put the field back up to 150 centimeters so that we have this nice resolution of our sphere as we get rid of those crystal shards. Now, if we go back to the middle of our animation and let's dolly into the shards over here, we want to make it so that we have this disintegrating effect towards the edges. And we're going to use the MeshTools polyscale to achieve that. So let's click our MeshTools inset. We'll go to the INSYDIUM menu, MeshTools, and let's hold Alt and click the MeshTools polyscale. So we don't see a result just yet, but if we go to the polyscale and in the object tab, increase the amount percentage, we can see all of the polygons that make up our mesh start to scale down. It's a very beautiful effect, but we want this to occur just on those outskirts of our shards. So let's increase the amounts to 50% and let's just reframe our camera and hide the dope sheet so that we can see a bit more clearly in the viewport. So that's this button here. So polyscale, let's create a field to control this effect. So we'll go to the fields tab, click and hold on this button here, and let's select the spherical field. Let's get our spherical field out of this hierarchy just to separate it out. And we need to increase its size. Let's go to 200 centimeters. And we can already see the effect working nicely. But there's a few more things we need to do. We need to go to the remapping tab and increase this inner offset. That means that we have the full amount of strength within this inner sphere, and it then reduces in strength towards the edge. So that looks good for now, but our effect is actually inverted. We need to go back to the polyscales field tab, and we're going to modify this. So let's click invert on this modifier layer. If invert isn't there at the top, you can click and hold and find it here. So there we go. Let's hide these fields from the viewport quickly and dolly into this area, and we can see that we have the control now over where that disintegrating effect is occurring. We can make it stronger if we want to, so we can go back to the polyscale object tab and increase that amount. And of course, we can go back to our spherical field and reduce the inner offset to increase the amount of polygons that are within the realms of that spherical field, therefore scaling more of those polygons. Now if we go back to the start of the animation and hit play, the crystal-like shards are going to explode out of the sphere, and as they start to exceed the inner offset of our spherical field, the polygons will start to reduce in scale. Now let's go back to the picture viewer. And we can see that we have these illuminated lines. Let's just scrub backwards slightly and forwards, and we can see that the lines are not where we have those shards. They're beneath the shards, and they are illuminating the shards because of the glass material. So let's minimize this again. We'll go to the polyscale, hold down Alt, and then navigate to the INSYDIUM menu, MeshTools, and we're going to bring in the MeshTools edge spline. The MeshTools edge spline generates lines where we have polygon edges. So we need to go to the viewport's display mode and change this back to Go Rod Shading to see the effect. And now we have those lines in the viewport. We can disable that and enable it again to see the lines. At the moment though, we don't have any of the settings changed or any fields, therefore all of the lines are being generated and visualized. But what we want to do is use this linear field to determine where we have the lines, so that we just have the lines beneath those crystal shards. Let's click the edge spline. We'll go to the Fields tab, drag and drop the linear field into the Fields menu, and we can see the inverted result of what we're after. So again, let's click this invert modifier, and there we go. We have the lines beneath our crystal shards. Let's restrict this even further though. We want the lines to appear just below this base level of fracturing. So to achieve this, we're going to go to the modifiers menu and let's bring in a range map. Now we can range map our linear field without affecting its effects on things like the inset, for example. We can affect it on a second-hand basis. So let's go to the max output and start to reduce this. And now we can see that we are restricting that even further than the linear field was in the first place. So there we go, that looks fantastic. If we go backwards, we'll see that when the linear field moves up in the scene, let's just bring that in again, we will be revealing more of those edge splines. Perfect. So in the picture viewer though, let's go back and have a look. We don't have this on the whole time. So we have the drawing on of those lines, and then they start to move down with the linear field. So we can break this down into two parts. We actually have the MeshTools shortest path generating this draw on effect, and then we have a handover about there, and then we have those edge splines. And the handover is there because when we have the change in geometry caused by the MeshTools inset, the shortest path will have to recalculate all of its paths, and it's going to slow down Cinema 4D. So we're going to turn off the shortest path at this point, turn on the edge spline, and have that handover between the two. So let's go back to our scene. We're going to turn off the edge spline for now. Let's just hide the linear field as well. And we'll go to the INSYDIUM menu, MeshTools, shortest path, hold down Alt again, and click it so that the edge spline is within the shortest path. Let's go back to frame 0. And you can already see a path being generated. If we go to the Object tab of our shortest path and reduce this end slider, we'll see that path draw off. Then if we increase it again, it's going to draw back on. So let's go to the Display tab and turn on Show Start and End Points. As we can see, the start point should be blue and the end point should be red, and in order to see that in the viewport, we need to increase the size, and there we go, we have the start and end point. So these are the points that shortest path has decided to draw a line to. It's the shortest path between the 2 points. Let's go back to the Object tab and increase the end number Let's just have a look at this. We'll click the shortest path again and reduce that end percentage and then increase it, and you can see those paths are being drawn on. So that looks great. We need to go back to the display tab and turn that off again. But what we want is for all of the points to be connected. Let's therefore increase the end number to a massive number like 1500, and we'll increase the start number to, let's say, 25. There we go. Now let's turn on custom growth rate, and we need to increase this amount. So let's go to frame 40 where we have that change in geometry, and you can see the shortest path trying to figure out the new geometry there. So let's go back to frame 40. And you can see that not all of the paths have completed their journey. So we need to increase the growth rate. When you have custom growth rate enabled, the paths automatically draw on based on this growth rate percentage. So let's increase that to the point where we have all of those drawn on. And we can add some variation if we want to. So let's add 0.2% of variation. And now if we go back to the start and scrub this through, we're going to see those paths draw on. So at frame 40, we want to go to the shortest path and disable it. So let's disable it now, keyframe that, and go backwards a frame, and then enable it again. And then we'll go to our edge spline, keyframe this disabled, go forwards a frame and enable it, and then keyframe that. So we're going to have a handover, and it's not going to be perfect. We're going to get a few jumps, but that's because we don't have the settings honed in our shortest path. So we need to either increase the starting number or the end number, or give this a bit more of a chance to draw in. But for this video, it's going to work fine because in the picture viewer again, we have this twisting animation as the sphere spins even faster at that point. And so we're not going to see that jump between the two. So let's hide the picture viewer again. And let's change the edge spline and shortest path colors to the cyan color. So we'll go to the edge spline. Let's drop this down and let's choose this beautiful cyan color here. We can copy this, go to our shortest path, and go to the basic tab, and let's change the display color to this cyan color. Beautiful. So that's the basis of our crystal shard animation. Now let's bring in the spinning of our sphere. So we'll bring in the timeline again. Let's group our shortest path. We'll call this sphere rotator. Coordinates tab. Let's go back to frame 0 and keyframe the heading of our sphere rotator. Then we'll go to the last frame and let's increase this to 720 degrees. And let's just drag and drop this into our timeline. And there we go, we have the keyframes there in the timeline. So our sphere is going to rotate throughout the animation. If we go to the F-curve mode, we can see that we have the default easy ease of our sphere rotator. We actually want this to be linear. So we'll click this linear button. And now we have a constant amount of rotation throughout the animation. So the reason for doing this is we can now navigate to frame 40, and we can control and click to create a new keyframe. And we're going to not be disrupting the flow of the easing. So we can always add easing afterwards. Let's go to frame 80 and create our second keyframe. Then frame 180 and frame 220. So it's between these 2 points here and here that we want to have the increased amount of rotation. So let's select all of these keyframes and bring that up. Let's have a look at the increased speed. So we'll go into our sphere rotator and let's just disable these. The shortest path and the edge spline will enable and disable on their own, but that's fine. Let's just have a look and see how this plays through. So we can get away with much more rotation than that. Let's just bring that up even more. Okay, that looks good. So now we know how much roughly to increase these as well. So we'll bring those ones up to like so. Just check that out. Perfect. Okay, now we can select all of these and add easing if we want to. Okay, so now we've reactivated our MeshTools system. If we hit play, we're going to see a bit of a problem. The shortest path has become misaligned with our mesh. We can see that here just before the handover. So that's because we need to have our shortest path above the rotated null. Otherwise, the shortest path is being recalculated improperly. So let's take our edge spline and put this above the shortest path. Then we'll take our shortest path above the sphere rotator and make the sphere rotator a child of the shortest path. And now if we hit play, we're going to see the correct results. We have those lines drawing in, we have the handover to the edge spline, those crystal shards come out, and those outermost points of the sphere are going to scale down due to the polyscale. Now all we need to do is keyframe our edge spline so that the lines disappear towards the end of the animation. So let's go to frame 240. We'll go to the end growth and let's just show you what happens. So if we reduce the strength, those splines start to disappear. So let's keyframe this, and then at frame, let's say 270, let's bring this all the way down to 0%. And let's play this through. Okay, so actually let's take this out further. So we'll go to our timeline and let's bring in the edge spline. We want to take this key and let's bring it out to frame 300. So that looks very good, but I'm not liking the way that we have this dark patch in the middle that appears. So instead of keyframing the end growth, let's get rid of that by holding Control Shift and Alt and clicking the keyframe button. That's going to get rid of all of the animated keyframes there. Increase that back up to 100%. Let's use a shader, and we're going to have a bit more control over where we have those disappearing lines. So again, let's select a noise shader and we can keyframe the tolerance instead. So let's reduce this all the way down to 0%, keyframe it, and this keyframe is meant to be at 240. Then at frame 300, let's go back to the edge spline and increase the tolerance all the way up to 100% and compare that. There we go, that's much nicer. Let's take this out even further though. Let's go all the way to the end of our animation. Okay, so let's hide our timeline again, and we can add the material now. So let's turn on the inside light and open up our material manager and attribute this crystal material to our sphere. So our sphere now has that crystal material, and if we hit play, we're going to see a really beautiful effect in the viewport. Let's get a viewport render going, and we'll come back and have a look when it's finished. So here's our animation. Let's hit play, and we can see that base sphere be manipulated by our complex and highly detailed looking MeshTools system. It's very intuitive, very easy and fast to set up, and you can create some beautiful animations.